All right, and we're live. Hello, everyone. Welcome to another webinar. I'm very excited to be here with you today, and we have a great guest with us that I'm excited to have on the webinar with us. So I'd like to introduce Baptiste Bouffaut, who is the CTO of Ponicode. We'll dive a little bit into what Ponicode is, but Baptiste, do you want to maybe give yourself a quick introduction to everyone that's tuning in?
Yeah, sure. Hi, everyone. I'm Baptiste. As Mackenzie mentioned, I'm the CTO of Ponicode. And Ponicode is a startup, and we implement an AI platform that aims at helping developer develop faster and better. And to do that, the first skill we gave to our AI is the ability to automatically generate unit tests based on the code that has been written by developer. But the ambition is to implement much more skills that will help developer in their day-to-day life, like helping them writing documentation, helping them refactoring their code, helping them doing other stuff that again will help them in their day-to-day activity.
So, yeah, it's really cool. I love this. I love this concept. I love where we're heading in this AI when it comes to helping developers, because it allows us to really focus on what we can do, what we love to do, which is creating new things. And today we're going to be focusing a little bit about how we could utilize this AI for code quality and how that really translates into what we can do in security. So, just while we wait for everyone to tune in, a friendly reminder, if you haven't been to one of these webinars before, we love participation. So you'll notice already we have some polls down there. We'll introduce those as we go. If you have questions for myself, but probably more Baptiste, then you'll notice a button at the bottom of your screen that says Ask a Question. These are the easiest ways for us to be able to see them. So we'll have a Q&A section where you can ask any questions, and we'll try our best to answer them and participate in the chat. And those that are participating get a chance to win a swag bag, which usually is a GitGuardian swag bag, but today it's going to be a GitGuardian Ponicode hybrid swag bag. So you'll be looking very snazzy out there. So make sure you participate to get in the chance. And also, we just like hearing from you. So first steps of participation, whilst we're waiting for a few more people to chime on, whereabouts are you all tuning from? So Baptiste and I are both in Paris, in France at the moment. I was very, very excited to see that we had someone registered from my home country, which is New Zealand, from Auckland, but I think it's about 4 a.m. But if you are tuning in from New Zealand and Auckland at 4 a.m. and you decided to get up just to see this webinar, then let me know. I'll be so happy. I'll send you a treat. So Bordeaux, Cedric, welcome. I recognize that name. It's great to see you tuning in, Cedric. Texas, Bangladesh, Atlanta, Lagos, Nigeria. Anyone tuning in from New York? I'm going to be in New York. We're going to have a live meetup in New York in next week. So if you're tuning in from New York, check out the meetup group there. Michigan, Lagos, Nigeria. Oh, awesome. Nate, New York next week. Well, maybe we can catch up in New York at the information security meetup. How can you join? Excellent. I'll see if one of my helpers is online. Ziad or someone else. Could you post the link in the chat to the New York meetup so that people can get this? All right. So first poll, and then we're going to get straight into some content. But under the poll section, let us know. Are you currently familiar with the concept of shifting left or shift left? It's a security concept. So let us know if you've never heard of this before, you have heard of it, or if you're actively implementing it. So the Thomas Sigurd just posted that in New York. So if you want to come to the New York Register, you can register for free at that link there. Would love to see you. And if you're just here for the prizes, I will have prizes in New York as well. Okay, and before we get started, I have one other quick housekeeping announcement to make before I hand it over to Baptiste to explore more into code quality. I'm excited to say we announced yesterday that GitGuardian just raised Series B. So we raised $44 million to help us protect code. So this is exciting. If you're new to GitGuardian, if you've been with us for a while, you're going to see some massive improvements, some new features. And also, if you are interested in the cybersecurity space, we're trying to add 100 new faces to our Guardian team this year. Well, not this year, it's almost over, but in the coming year. So please reach out to us if you're looking for opportunities. Would love to hear from you, especially if you've already been using it. So without further ado, now that we have the housekeeping announcements out of the way, I'm going to close my screen. I'm going to close my, how do I start? There we are. And Baptiste, I'm going to leave it over to you to share your screen, and maybe we can dive into this topic of code quality and how it can affect code security.
Yeah, sure. Can you see my screen?
Yep, it's just popping up. Yep, perfect.
Okay, great. Well, thanks a lot, Mackenzie, for the introduction, and I'm very happy to be there tonight to share with you what is our vision about the code quality and code security at Ponicode. As a quick introduction, I'm pretty sure everyone around the table knows that code quality matters and code security as well. But do you know why? Really, do you have concrete example why it is really so important? Maybe someone in the room. Do you have some experience about any code quality issue or code security issue that brought some difficulties in your business or in your activity? Okay, no, let's move forward. I gathered a couple of examples. If you remember well, a couple of years ago, Ariane 5, which is a European rocket, broke a couple of seconds after takeoff. And so it was years of work and millions of euros of loss. And why Ariane blew up? It was just because of a big int overflow problem in the inertial computing system that has not been tested at all. That blocks the system of the rocket, and the rocket blew up.
So that this was purely a system, computing system and software system that hadn't been tested before the launch of
exactly.
this.
And to
Wow.
be more precise, it was a copy-paste from a previous version of Ariane. And it has been tested in the previous version, but they decided not to test again because it used to work on the previous version of the rocket. But unfortunately, it was not enough.
I'm sure we're all guilty of this, the copy-paste. The copy-paste to come bite us back in the bum.
Exactly. Second example, you've probably heard about SolarWinds, which is a platform that deploy tons of software all around the world in most of companies in the world. And because of a breach in their system, some hackers introduced into the system and put some malware pieces of code into software that has been spread out all around the world in lots of companies. Even today, not all the companies are aware if they are concerned by this problem or not. So it's a huge issue, a huge problem, just because somewhere something has not been well implemented or tested, and a hacker was able to introduce into the system. So again, very small things could have avoided that, and the impact is just huge. One more example, in 2015, there were a mistake in the software that computed the remaining duration of retention of prisoners, and this mistake made some prisoners to be released before the normal date of their release, and for some of them, long before their normal release. And it was just a computation mistake in a small piece of code, a piece of code that computes a duration, so an integer, nothing more. So again, very small mistake or very small thing that has a huge impact on the prisoners. And the last example you've probably heard about as well is regarding PayPal. In 2013, there were a data breach in their system, and during 4 days, there were a ransomware, and during 4 days, PayPal was completely down, and it costs a lot to PayPal. And again, because of data breach, so something that has not been found, tested before it goes to production, permits someone to introduce into the system, and it costs billions to PayPal. So, where do we stand today? Today, if we look back at what is software engineering for over the past, let's say, 10 years. Of course, we got lots of new tools that helps delivering, testing, building, deploying with all the DevOps strategy and DevOps blueprint. So software engineering made a lot of progress, but there was no real revolution in software in the software industry. And at Ponicode, we believe that the software industry will have a revolution like the automotive industry, the car industry got 40, 50 years ago, when this industry knew a big crisis, a big quality crisis. For 50 years ago, all cars were all the time out of order. There were a lot of quality problems on cars, and there were a revolution, and a lot of tools, a lot of processes were introduced to drastically improve the quality of the car. At Ponicode, we are convinced that the software industry has to make this revolution, and probably AI will help on that. But I will deep dive on that later in this presentation. Quick overview of the market, of what we are talking about. Today, the developer spend sometimes to code. Of course, it's the heart of his job, but there are many of the things that a developer has to do. I won't deep dive into the precise list. I know all of you know that. All those tasks are the responsibility of the developer. But at the 21st century, some of those tasks should be, let's say, automated. At least the developer should be helped to do that, and he should not have to do this by himself. And for some of those tasks, like security issues or investigating bugs, those tasks should drastically reduced. If we manage to improve the code quality, developers should spend less time investigating bugs and doing some maintenance of the software. So again, at Ponicode, we don't think non-coding tasks will disappear in the life of a developer, but what we are convinced of is that developer needs, I want to say, exoskeleton to be helped, to be augmented, so that he can do all those tasks very, very quickly, and he can really focus on coding and bringing value to the product the developer works on. Very last market overview. You probably have heard about those figures, but today the volume, the impact of non-quality code, so the bad code impact, represents today $85 billion per year. I don't know if you represent it, it's huge. It's a huge amount of money. Today, $85 billion per year are lost in translation because of non-quality code. And I don't talk about bugs, maintenance, and security issues that represent $300 billion per year. So definitively, we enter we enter a period where those things will have to be improved. We will have more and more tools that will help developers spending less time on that, and permitting companies spending less money on non-quality code and on bugs and security and maintenance issue.
So just so I understand that, because that's quite surprising. $85 billion of bad code. So that's just kind of completely avoidable code that doesn't follow practices, and this is excluding blatant security vulnerabilities and bugs that are introduced. So just that bad code, $85 billion in net loss in the industry.
Yeah. You will
Wow.
understand. You will understand later in the presentation why bad code has such an impact. But yeah, that's just huge. Okay, so maybe the first question we should ask: what is a healthy code? Again, I think I will probably learn nothing for all of you around the table, but I think it's important to say it again. An healthy code is a code where each component, each function is one purpose. So one function does one thing, one component does one thing, and so on and so on. A piece of code should be efficient. It means well written, compact, easily readable, few lines of code, a few numbers of parameters for functions, and so on and so on. Secure and safe. So to ensure a piece of code is secure and safe, there is no other way than testing it, and we will be discussing this a bit later. And a piece of code must be tested. Here it means the behavior of the code must be tested. The fact that there is no regression in the code must be tested. The security, as I mentioned just before, of this piece of code must be tested. And probably tomorrow we will have other kind of tests, like performance testing, and maybe one day, and we start seeing this, some environmental impact test as well. And last but not least, a piece of code, a piece of healthy code must be documented. And on the right, you probably all know and recognize this pyramid. The ground foundation of the pyramid of a healthy code and a healthy software factory is obviously a good code refactoring. Good code refactoring is a code that follow what I mentioned just before: one purpose, efficient, documented, secure and safe. When you have this strong foundation, it's very easy to implement documentation. So that makes even more robust and even more healthy. Then you can easily implement some unit testing, and you can also easily implement some static application security testing. And then you can also add some integration and API testing on top of that, but you need less. If you already have a good coverage and a good coverage with unit testing, you don't need so much integration and API testing. And at the very top, you will have some end-to-end testing and some dynamic application security testing. But again, you need even less, because you already have the previous layers that guarantee the quality of your code. So that's very important to keep in mind, this pyramid, because you will see in the following of the presentation that most of the time you have the inverse pyramid in the industry, and that's not good. So this is one of the questions in the poll.
Yep. This is in the poll here.
Yeah. So can we have a look at some results?
Yeah. So are you familiar with the concept of shift left? We have 32 votes no, 9 votes yes, 0 votes actively practicing principles.
Okay, that's interesting. I would have supposed that more people knows what it is, but that's good. That means that my explanation might help. So that's good to know. So what is shift left? This graph represents, so you see on the horizontal axis, let's say the software development process, requirements, design until deployment and support, and this is what we observed in most of the company today. What the red curve represents the cost of fixing issues depending on when the issue is identified. So as you can see, the latest the issue is identified, the most expensive it is to fix. And for your information, it's a huge factor. It's almost a 1K factor between on the cost to fix a bug when it's discovered when already running in production, compared with when it's discovered when it's on the laptop of the developer. So a 1K factor. It's just huge. And unfortunately what we observe today is that most of companies do a lot of tests very late in the software development. When I say very late, it's far after the development phase, and it means bugs are identified too late in the process. It means it costs a lot to fix the bugs. The ideal way of doing is shift left. It means you should test earlier and you should test all the time. If I make a comparison with the previous pyramid, let me step back a bit. Sorry, with this pyramid, the tests, when you do some tests at the very right of the software development, most of the time it's the top part of the pyramid. So it means end-to-end test, integration test, API testing. Those tests are very, very expensive to create, and they are very expensive to maintain as well. So if you put the fact that in this case tests cost a lot of money, plus the fact that bugs are expensive to fix, you can easily imagine why we have this $55 billion per year market. It's because of this. The ideal situation is that you do most of your tests at the very left, and this is the reason of shift left. And when we say at the very left, it means when the code is still in development in the branch on the local computer of the developer. Because as long as the code is still in local branch in the development computer, The tests are very easy to write. I don't say it's I don't say it's not boring to do it, but it's easy to do it. So I'm mentioning unit tests especially, and when the bugs, when unit tests crash locally on the laptop of the developer, it's very easy to fix it. It doesn't cost a lot of time. So it permits, if everyone does that, it permits to do less complex and expensive end-to-end testing, integration testing, and there are less bugs in production, and so bugs are far less expensive to be fixed. That's shift left approach. Mean test as earliest as possible and all the time. It should be continuous, and it's true for functional behavior regression testing, but also for security testing, and we will deep dive about that just after. Testing every time early in the process is the key to ensure code quality, code security at let's say low cost. So what it means in terms of processes, in terms of toolings, what is the impact of this in a software factory? So I won't deep dive into details into these slides. It's an exhaustive representation of what is DevOps environment, but it's even more. It's a DevSecOps environment. I don't know if you are familiar with that, but no, we are not talking about DevOps anymore, but we are talking about DevSecOps because the software industry realize that security must be completely integrated in the end-to-end process of software development. It's not something that should happen precisely somewhere in the process. It must be all the time, everywhere during the process. So it means new kind of tools have been created for years now about application security testing. It is static tools, dynamic tools, interactive tools. But now security tooling is really definitively part of the DevOps tool chain and factory. And now we are talking about DevSecOps. Here is a simplified view. Again, with this horizontal view that follows the development process, a high-level development process, I want to say. And it illustrates exactly what I just said. Security testing must be everywhere in the process. So you should start when you start planning and designing your application, doing some thread modeling, thinking about what would be the public endpoint of your API or the public interface of your application. While you are coding, you should have some static analysis, static code analysis, Git controls, and GitGuardian. You are a great tool for that, and thanks for that. Obviously, you have some specific security unit testing. You should have review dedicated to security. I don't say dedicated, but code review should include also security aspects of the code. And then during the build, during the QA, you again have the pyramid. So most of the tests should be on the left, based on the shift left concept. But later in the process, you still have some other kind of tests, but you should have less because those tests are more expensive to create and more expensive to maintain. On this slide, I wanted to highlight the fact that what we observed in a lot of companies today is that despite the fact that there are some very powerful CI/CD tools today, the end-to-end delivery process is very complex to fully automate because it is complex. And now that we are introducing more control on security, and maybe tomorrow there will have more and more control. As I previously mentioned, we might have one day some performance testing, performance unit testing, and maybe some environmental impact unit testing as well. So let's say the control pipeline and the different gates a software must go through during its whole life cycle will increase and will be more and more complex. So this is one of the challenges we have today, and I think there is lots of rooms of innovation and improvement in all the CI/CD platforms and DevTool platform to help automate more and more, to deliver even faster and to have very high confidence in the quality of what is delivered. Okay, so what is the link between code quality and code security? Because as I mentioned, a secure code is one criteria of a good quality code. But it's not only that. If you remember the pyramid, so what we observe today is that in most companies we do have this inverse pyramid. It means you have weak foundation in your code. It means the code is not so well refactored. You have huge functions with tons of parameters. The code is very complex to maintain. The code is not self-purpose. It's not efficient, and so on and so on. So if you have these weaknesses in your foundation, it means the documentation is not easy to write, because you reading the code, you will have difficulties to write down the documentation, except if you do the documentation first. But writing the documentation after writing the code, when the code is very difficult to read, it's almost impossible. The same for unit test and static application security testing. The more complex is the code, the less well refactoring is the code, the more complex is to write powerful and efficient unit tests. And it's even more boring to do it. And this is one of the reasons why most of the companies don't implement unit tests, because it's difficult to implement unit tests when the code is not well refactored. And this is the reason why you need even more integration and API testing, and you need even more end-to-end testing and dynamic application security testing tools. And the problem is that, as I mentioned previously, those top-level tests are very, very expensive to create and very, very expensive to maintain. And first, and the second is that the risks that there are still bugs at this level of the software lifecycle is very high. And this is the reason why there are a lot of bugs into production for companies that have such kind of inverse pyramid. So what is important to keep in mind here is that good code quality, so well refactored code, efficient, secured, well documented, self-purpose, one purpose, is the key to have a very strong foundation of all your software and all your software factory. Because on top of that, you can really build this pyramid in the right order with a strong unit test, less integration and API testing, and even less end-to-end testing. Okay, so what's next? What's the future of that? Today, all of you know there are tons of test tool. So you have unit test tool, continuous testing, web, mobile, performance, API, and so on and so on. And you also have a lot of code quality analysis tools, static analysis, dynamic analysis, and so on. What we observe today and what we believe in at Ponicode is that we are pretty sure that AI-powered system will completely disrupt these silos, because today it's really complex to implement efficient tests, as I mentioned, and so the platform are complex, the tools are complex, and most of the time the tools are dedicated to one specific things. Sometimes they are dedicated to one specific language or one specific IDE, or so it's this is one of the reasons why there are so many different frameworks and tools. what we believe in is that AI will permit to have some scalability in that, because it's far easier to implement language support thanks to AI-based system. And our idea, and we are convinced at Ponicode that as soon as we have a very strong AI technology, we could implement different kind of skills, different kind of tools that will help building this strong peer pyramid. And our belief is that AI will permit to inverse the pyramid a lot of companies face today. If you have a tool, if you have some helpers that first help developer writing well refactored code, then if you have some helpers that help developer writing good documentation, then if you have helpers that help writing unit tests and that help writing application security testing, and it means you will have a very strong pyramid, and you will require less, and you can also have AI for integration and API testing and AI for end-to-end testing. But we are convinced that AI will, on all those different stages, AI will augment developers. All those tasks will still be under the responsibility of the developer, but they won't be alone anymore to do that. They will have their coding partner based on AI that will help them, and it will be far easier to move from this inverse pyramid to the real strong, efficient pyramid that permit to guarantee code quality and code security. And that's the end of my presentation.
Thanks, Baptiste. We've got some questions, and we'll get to that too. But I have a question for you too. It's really interesting, and what I love about the presentation is that kind of continual testing of it. But my question is, would have this been possible at all before AI? How important is AI in making it possible that we can create this coding partner for developers to be able to effectively move forward in code quality?
Yeah, that's a pretty good question. So as you have seen on the market slide, there are a lot of tools, and most of them didn't wait for AI to implement some very valuable system. What AI will permit is to implement even, I think, after doing some R&D, and this is what we did over the past 2 years in Ponicode. When you have this strong AI technology, it's very easy to support any new language, even to support any new feature, any new kind of testing. As an example, just to give you an example, the Ponicode one, we have this AI technology today, and thanks to the technology, we are able to generate unit tests. That's the heart of our offering today. But we are also able to generate documentation with no effort, because it's the same technology of AI on code, of
right.
Code understanding. And tomorrow it will be, let's say, easier for us to implement refactoring assistant, as an example. So it's a very powerful technology that will permit to accelerate the delivery of new services and new features.
Okay. So I'm going to dive into some of the questions that we have here. We'll have a bit more time for questions, so I maybe won't do all of them now. But if you do have a question, there's a question tab down there. Be sure this is one of the rare opportunities you get to ask a CTO of a technology company a technical question. So definitely jump in and embrace that. So the first one I have is we had Mohammed asking a little bit about SQL injection. So this is a security vulnerability. How when we're talking about security vulnerabilities like injection, like cross-site scripting, these types of things, how does kind of the AI and the power, how does this contribute into us eradicating these kind of coding errors? And can it, or is this Is this like a different tool that can do that?
Well, obviously, AI is not magic. It is not magic. It means some data breach doesn't rely on software only. There are some network configuration as well, and for those kind of leaks, I want to say, you will still have this integration and hand-to-end test. But this is, I think, for me, this is the only reason why we will still need this end-to-end and integration testing, just to be sure the configuration of the system, including the network layers, are robust enough. But in any case, where AI helps is that what is important, AI can learn from the previous experience. So it means each time there is a new breach, a new incident, or a new leakage that is identified, the system will be able to learn as well and to continuously improve. But it's not magic. I'm not saying that AI will permit to solve all security issue and all quality issue. It will help.
Okay. Yeah. No, that makes total sense. All right. Another question here. Yes, the presentation will be available offline, so you'll be able to rewatch this replay too. I'll just do one more question, then we'll move forward. We had some questions that want to go a little bit into maybe understanding the different offerings that you talked about. So you talked about SAST, static application security testing. There was dynamic application security testing, SCA. Maybe could you maybe expand a little bit on these and if and kind of how these fit into the overall picture?
Yeah. So you gave the example of SAST and DAST. Just for information, it's exactly the same for functional unit testing. There are two types of, according to our vision at least. You can have two types of tests. So the static test, it means you read the code and you try to find based on reading the code only to find some bad patterns, some things that are not wrong, some things that are not working well. That's static analysis. And again, it's the same for unit tests. And then you have dynamic. It means the dynamic tools analyze the code running on a machine. So it analyzes the runtime of the software. It permits to have very, very powerful additional information in addition to what you can see reading the code only. At Ponicode, we are currently working on, and that's part of a patent we put. We are convinced that dynamic analysis of running code will permit to implement very, very powerful bugs detection system and to write even more efficient unit tests.
Okay, yeah, perfect, very clear. Okay, so I have some questions here too, and this next one I actually put up as a poll because I was curious to see. So, but I want to get your interpretation of it before I let you know what everyone has kind of said about this. But major security incidences that we've seen. Now, you mentioned a lot of them, but we are at no short supply of being able to list major security incidences that have happened on the. How big of a component is being able to implement this code quality and this automated detection of code quality and to preventing incidents like this? Can we essentially eradicate some of these incidents? Where do we sit in kind of moving forward with this ability in code quality?
For me, as I mentioned previously, so we probably won't completely remove any kind of problems just doing some very powerful unit testing, security testing. But if you remember the example I gave in the beginning of my presentation, at least all those examples could have been avoided if strong unit tests have been put in place. But probably others won't have been avoided. But yeah. So probably I don't know how far we can go, but I think today we are very weak. The progress, the possible progress is just huge.
Yeah, no, I totally agree, and this is a lot of what we talk about at GitGuardian, is that in the world of cybersecurity vendors that we are at, you see a lot of hyperbolic statements from the magic solution that fixes everything, and you just need this magic solution. There isn't a magic solution. It's consecutive work that we need to have and implement layered security and automated code, detecting code quality, enforcing code quality, and having that co-pilot that helps you is oh, my battery's just run out, so hang on, I'm gonna have to fix that. But let me just share my screen for a second. Having a look at the polls, the majority of people agreed with you on that. 29 votes of people said yes, some security incidents could be avoided with code quality. And there's still some people out there that are skeptical on the. I have another poll here while I quickly fix a technical issue on my end. I want to know, does anyone out there currently use a code quality solution? And in your current, I want to see what the maturity of this is. I'm sure Baptiste already has some idea.
Yeah, that's a very good question, and the answer, and we usually ask this question to all our customers, and the answer is all the time the same, and it is yes. We do have some code quality checking, and there are some major vendor and major solutions on the market that are widely used all around the world. So yes, the answer is yes. But what is interesting in the answer is that yes, but we don't really use it because most of the time it's very difficult to take activable actions from the outcome of what the code quality analysis tool gave to us. This is something we heard about our customers. It means that most of the time the static analysis code quality tool there are on the market gives hundreds of issues, hundreds of bugs, or hundreds of things to improve in your code, but you don't know where to start from, and you don't know what is important to do first. So all our customers say, but at the end we have it, we look at it sometimes, but we don't really use it in our software development process.
Yeah, I can certainly see that in what we have. It's sometimes putting something in and not utilizing it to its effect, or if the tool produces too much noise, then it just becomes another thing causing more issues rather than actually solving problems. So Baptiste, what I thought we could do here is, I've seen Ponicode in action, and I think it helps to kind of get a visualization of actually what we can do in code quality and code quality testing. Are you able to do a quick demo of the of the sloop now? That'd be fantastic.
Yes, let me share my screen. Okay, so I will do it quickly, but I encourage everyone to give a try and to send us feedback about that. So I'm in my VS Code. Ponicode today is available as an extension on the VS Code marketplace. We are also available on IntelliJ marketplace for Java language only, but with a alpha support. It has just been released last week, so it's very young. We don't have the same maturity on Java than on JavaScript, TypeScript. I will show you today. So it's quite easy to install. You just have to search Ponicode on the marketplace here, and then you just install it. It takes a couple of seconds. For the first time, just after you have installed it, it will propose you to log in, and seconds after you install it, it's already available and usable on your project. So let me open a file. So here it's a TypeScript. This is a very simple function, but this one is let's say we can say that it's well written. it's efficient, it's compact, it's readable. And when you have Ponicode extension activated, you have the little ponies on the left that permit to show you when functions are unit testable by Ponicode. So if you want to unit test there, you just have to Ponicode unit test, and then you have this nice interface that's open. Sorry, I will remove this. So what do you have in this view? Let me. Is it big enough? You can see.
Yeah, I can see.
So there are two sections in this view. On the bottom, you have some unit test suggestions. And what is a unit test for Ponicode? It's a line in the table with some parameters suggestions for the function and with some assertions suggestion for the corresponding parameters. And if you want to add some tests, you just have to click on the plus button, and it adds the proposal and the suggestion from Ponicode in your unit test section here. So, sorry. As you can see here, I have added 2 unit tests in my unit test, and I gain 100% coverage. And just for your information, Ponicode generates unit tests in a jest format for JavaScript and TypeScript. So it's not black box at all. It really generates tests that are human readable by developer, as you can see there. Here, this is the file view of what you have there in the table view. So that's very powerful, and you see in a couple of seconds, I generate two unit tests with 1% coverage. So coverage on this function is very easy, so it's not a big deal, but it's very smooth. What is important to what is important to keep in mind, especially in the context of code security we just discussed about, is that the power of our AI is the capability to identify some happy paths for the function, so some set of parameters that will permit to test the normal behavior of the functions, what is expected from the function, but also edge cases. And regarding code security, that's where we will have a lot of value, because most of the time, the problem that implies some security issue comes from some edge cases that has not been identified and well catched in the code. So as you can see here, Ponicode made some proposal on some edge cases with some infinity, 0, and so on and so on. Let me give you another quick example with a much more complex function. Here on this one. Yeah, so here you can see get and validate department. So the function is less robust, a bit longer with several if, else if, and so on. So I have my little pony, I can unit test it. And here again, Ponicode suggests some inputs that will permit to test some happy paths, the normal behavior of the function, and also some edge cases. And you can see that with the little orange box there. And you have some coverage information, meaning that if I take this unit test, I will have good coverage. If I add this one, I will gain 5% coverage. And I'm almost there, because there is this, as you can see here, there are some red lines that are not covered by unit tests, but that's well, that's nothing here. And I will also add some edge cases. Yes, so there are some obvious edge cases here, like undefined, but there are also some edge cases that are less obvious. And what's important to see on this example is that the input generated by the AI of Ponicode can be very, very complex. As you can see here, if a human developer has to write this test, he has to write manually this kind of complex objects. So let me show you there. So you have this complex JSON. So it's very annoying and very boring, but Ponicode is able to generate it for you. And it also permits to generate some edge cases inside those kind of complex objects. So as an example, if you have an array in your JSON, you will have here, as an example, empty array in this specific keys of the input parameters. So it will very permit to secure your code by running those unit tests. Well, so and just to let you know, so you have this nice web UI in VS Code. We also have a flash test feature, which is a feature where you trust the AI and you don't want, let's say, to manually pick the suggestions, and you let Ponicode choose the suggestion for you, and it automatically generates pick up some input suggestion and write down everything into the test file here. And this feature permits to have to implement a coverage, what we call coverage catch-up. So when you have a huge project with very low unit tests, you run Ponicode flash test in our CLI, because we also have a CLI, and it will automatically generate for the whole project some unit tests on all functions that Ponicode supports, because Ponicode doesn't support all type of function today. And the developer just need to maybe have a look if they are confident with the test that has been selected by Ponicode by reading the file. But it is very, very powerful to starting from zero to reach a very good level of code coverage in minutes.
Wow.
Yeah, and that's it. I think we are running out of time soon. So
Yeah. Well, we've had some great questions come in. One in particular from Ian that I want to ask, and I think it's a good timing now because we're talking about using that CLI and putting a bit of trust in the Ponicode to create the unit tests to do that. So Ian's question is, putting all the eggs in the AI basket, how do we validate that the AI is improving quality in the correct way, in the right way? So how do we go about in Ponicode training the AI, making sure that it's improving in the correct way?
Yeah, that's a very good question. So for me, the best and almost the only way to really demonstrate that Ponicode helps is to observe the number of bugs in production. The fact is that we don't have enough story before us to really being able to show this decrease of bugs in the customers we do have. That's continuous improvement coming from our team. We are continuously looking at how many tests are accepted by developers. Because you can also reject them. So it gives us information about if the suggestion is good or not, and we are improving based on those based on that.
Yeah, very cool. I thought that was a great question to ask, Ian. So thanks for putting that one out. Well, we're coming to the end of it now. I'm just going to run through. We have some final polls that I'm actually I'm curious to see some answers to. So we put out this one here in the poll too. What do we all think? This is the last webinar that we have for the year. So I'm curious to know, what does everyone think of the state of cybersecurity for 2022? Are we going to get reduced reportable breaches? Are we going to get roughly the same amount a year? Is malicious activity going to increase as it did going from 2019 to 2020 and 2021? Do we expect it to get so bad we're going to have widespread disruptions? I also have a fifth option in there, which is currently hiding in my doomsday bunker. There's a few people that are currently hiding in a doomsday bunker, according to this poll. But look at the results now. I think so. Most people expect it to stay the same. Some people expect it to kind of get worse. Very few people expect it to get better, and a few people expect it to be horrible. Baptiste, what's your prediction for 2022? Where are we heading in the immediate future for the state of cybersecurity?
Well, very short term, it will. I think it will. It will be good. I mean, for sure. We will be improving drastically, and even if there will have more and more attempt to crack, I think R&D and startups and huge company will go faster than the hackers, for sure.
Absolutely. I think AI in this area is going to be key in making sure that we can get the cutting edge. I feel like the last few years, attackers have had the edge, and now as we're becoming more mature, we're understanding it, and we're getting great products like Ponicode and, of course, GitGuardian out there that we can get better. So I want to thank. I got to announce the winner. Oh, almost did this. Well, the winner, we have a winner by a fair distance. I think Nate knows who he is. So so thanks for participating, Nate. You had the most amount of engagement that we have. So we'll make sure I'll reach out to you after the webinar, and we'll make sure that I'll reach out to you. We get that. So Nate Vadel, congratulations on winning the swag bag. We have another webinar coming up. So this one is on the 19th of January. Thomas, if you're in the chat, can you paste the link, or Ziad? I see Ziad's in there too. Can you paste the link to the next webinar? So it'd be great if you guys can register for this so we can kick off the new year. We're going to be talking with Rewind about disaster recovery, going through them. And there we have. And Ian, one last question, Baptiste, from Ian, because I see that he's want to know the roadmap for more languages. Where does Ponicode have a roadmap for adding more accepted languages into the platform in the future?
Yeah, sure. So we just released an alpha version of Java. The next one, to be quite frank, will be probably C#. Because our market is B2B, our customers are big companies, and most of them are very legacy code and very low tested legacy code. So C# will have PHP for the same reason. So it's not sexy language, but that's the market. That's the reality of the market.
Excellent. But we can expect as Ponicode grows, we're going to get more languages, of course. Exactly. We're looking forward to it. Well, Baptiste, it's been awesome to have you. I've learned a lot. I hope everyone has enjoyed it. Well, thanks for being on the webinar. I hope we can have you again on as a guest in the new year. And if I don't see you or talk to you, I want you to have a great Christmas and Happy New Year.
Thanks a lot, Mackenzie, for the invite, and thanks a lot, everyone.
That's it for this week, guys. Make sure you register for the up and coming webinar. We have a link in the chat. It's going to be with Rewind, planning for worst case scenarios, disaster recovery on GitHub. Looking forward to that one. Thanks again, Baptiste. Thanks everyone for participating, and I hope to see you next time. See you.